All right, this video is dividing radicals. So the first step is to divide coefficients, then use the quotient rule. Okay, so the quotient rule, remember when you're dividing terms, you subtract the exponents. In order to be able to divide radicals, you have to make sure that they have the same index, and then you're just dividing what's underneath the radical together. Okay, after you have done that, then you want to simplify the resulting radical. So on number 1, so what's outside of the radical you put together, so 12 divided by 2 is 6. And then what's underneath the radical you can put together, 160 divided by 5 is 32. Then you want to simplify down the radical just like normal. So what's the largest perfect square that goes into 32 evenly is 16. And that is 16 times 2. The square root of 16 is 4. So we have 6 times 4. 6 times 4 is 24. So our answer here is 24 square root of 2. Okay, on number 2, 36 divided by 9 is 4. 1,250 divided by 2 is 625. Okay, on this one, we actually can simplify this down because the fourth root of 625 is 5. So that is 4 times 5, which just equals 20. Okay, on this one, we're using our quotient rule. So x cubed divided by x squared is x. And then y to the 9th divided by y to the 5th is y to the 4th. Okay, so then we're still underneath the radical. So we can't take the square root of x. So that goes in the second radical. The square root of y to the 4th, we can do that. So that goes in the first radical. Okay, but what is the square root of y to the 4th? Well, it's y squared because you just take the exponent and divide it by 2. So y squared square root of x is going to be our answer. On number 4, we have 28 divided by 4 is 7. Negative 16 divided by 2 is negative 8. M to the 6th divided by m is m to the 5th. Okay, and we are doing the cubed root here. The cubed root of negative 8, we can do that. So we'll put that in the first radical. You cannot take the cubed root of m to the 5th, so we want to break that down to m cubed. And that leaves in our second radical m squared. So the cubed root of negative 8m cubed is negative 2m, so we have 7 times negative 2m. And then we still have the cubed root of m squared. Then we want to put this together, so 7 times negative 2 is negative 14. So our final answer is negative 14m cubed root m squared. Number 5, 48 divided by 16 is 3. So we just have the square root of 3. That doesn't simplify, so that's your answer. Number 6, 40 over 27. Well, that's not going to simplify down. So we want to break that into two different parts. We're going to simplify each radical part. So we have the cubed root of 40 that we want to break down. So the largest perfect cube that goes into 40 evenly is 8. So that is 8 and 5. The cubed root of 8 is 2. So we have the 2 cubed root of 5. And then for 27, okay, the cubed root of 27 is 3. So that leaves us with 2 cubed root of 5 over 3 is going to be our final answer there. Okay, so we just took each part and simplified. Number 7, same thing. We can't do each part here, so we're just going to do the numerator and then we're going to do the denominator. Okay, in the numerator, we have the cubed root of 7x to the 5th. Well, you can't take the cubed root of 7, but the x to the 5th we can simplify down. So the cubed root of x cubed and the cubed root of 7x squared. The cubed root of x cubed is x. So we have x cubed root of 7x squared is our numerator. For our denominator, we can actually simplify the whole thing. The cubed root of 64 is 4, and the cubed root of y to the 6th is y squared. And that's our answer. For number 8, 32 over 81, those, let's see, those are not going to simplify just like that, but we can simplify down the fourth root of 32w. So fourth root of 32w breaks down into the largest perfect fourth that goes into 32 evenly is 16. So the fourth root of 16. And we have the fourth root of w. The fourth root of 16. Oh, I'm sorry. I forgot my 2. Because 16 times 2 is 32. So 2w. The fourth root of 16 is 2. So that's 2. Fourth root of 2w is going to be our numerator. So I'll pull that over here. For the denominator, the fourth root of 81, we can actually take the fourth root of 81, which is 3. So that just simplifies straight like that. And that's our answer. Okay. All right, this part down here, so it says rationalizing the denominator. So monomial denominators, you multiply the numerator and denominator by the radical. So we multiply both of these by the square root of 5. If it's a binomial denominator, you multiply the numerator and denominator by the conjugate, the same expression, but with the opposite sign in the middle. This is the same thing as what we talked about when we talked about complex numbers, and we talked about imaginary numbers, because remember, we did not want imaginary numbers in the denominator. This is the same thing. You do not want a radical in the denominator. So to get rid of that, you just multiply by whatever the radical is down here. So we're going to multiply the numerator and denominator both by the square root of 5. Okay, so then that turns into, well, 3 times the square root of 5 is 3 square root of 5. In our denominator, we have 2 square root of 5 times the square root of 5. Well, the square root of 5 times the square root of 5 is the square root of 25. And the square root of 25 is 5. So that actually turns into 2 times 5 down here. So really, that radical just kind of cancels out and you're left with 2 times 5. So our answer here, we have 3 square root of 5 over 2 times 5 is 10. Now, if this simplified 3 over 10 right there, then you would simplify it, but on this one it doesn't, so that's your final answer. Okay, on number 10, you can actually break this down to where it's the square root of 8 over the square root of 15. Okay, so we are going to multiply both the numerator and denominator by the square root of 15. So 8 times 15 is going to be 120. And 15 times 15, okay, is 225. The square root of 225 is 15. 120, you want to find the largest perfect square that goes into 120 evenly, which is 4 times 30. And the square root of 4 is 2. So this turns into 2 square root of 30 over 15. That's our answer. Okay, let's flip over to the back side. Number 11, so we want to multiply the numerator and denominator both by the square root of 7. Okay, so we have 3, 12 times 7 is 84. And then we have 4, and 7 times 7 is 49. Okay, so this turns into, let's go ahead and simplify down 84 as well. The largest perfect square that goes into 84 evenly is 4, so that's square root of 4 times square root of 21, because 4 times 21 is 84. In our denominator, the square root of 49 is 7, so this is 4 times 7. Okay, the square root of 4 is 2, so you're doing 3 times 2 is 6, square root of 21, over 4 times 7 is 28. Okay, now we want to simplify this down right here because these both divide by 2. So 6 divided by 2 is 3, and 28 divided by 2 is 14. So that turns into 3 square root of 21 over 14 is our final answer right there. Okay, on number 12. Okay, so we want to multiply both the numerator and denominator here. Before we do that, let's go ahead and simplify this down because 32 doesn't divide by 3, but we can simplify down the a's. So a to the 5th divided by a is just a to the 4th. So that turns into 32 a to the 4th over the square root of 3. Okay, now we can multiply both the numerator and denominator by the square root of 3. So 32 times 3 turns into 96 a to the 4th. And then the square root of 3 times the square root of 3 is the square root of 9. Okay, and so then we want to simplify it from there. So what's the largest perfect square that goes into 96 evenly is 16. Can we take the square root of a to the 4th? Yes, so it goes in the first radical. And that was 16 times 6. And the square root of 9 is 3. So the square root of this first radical, the square root of 16 is 4. The square root of a to the 4th is a squared. We still have the square root of 6 and we still have 3. 4 and 3 do not simplify, so this is your final answer. Okay, on 13, we are going to multiply the numerator and denominator both by the square root of 2. Okay, so the square root of 8 times the square root of 2 is the square root of 16. Negative square root of 2 times the square root of 2 is negative square root of 4. And this is over square root of 2 times the square root of 2 is the square root of 4. Okay, then you want to simplify. The square root of 16 is 4. The square root of 4 is 2. The square root of 4 is 2. So 4 minus 2 is 2, and 2 divided by 2 equals 1 is going to be our answer. 14, we want to multiply the numerator and denominator by the square root of 12. So 3 square root of 2 times the square root of 12 is 3 square root of 24. Square root of 6 times the square root of 12 is the square root of 72. Square root of 12 times the square root of 12 is square root of 144. Okay, then we want to simplify. So the largest perfect square that goes into 24 evenly is 4. So that 3 we just carry over. We have 4 and 6, because 4 times 6 is 24. Okay, the largest perfect square that goes into 72 evenly is 36, and that is 36 times 2 is 72. The square root of 144 is 12. Okay, so then let's simplify. The square root of 4 is 2, and 3 times 2 is 6, so that is 6 square root of 6. The square root of 36 is 6 square root of 2, and we are over 12. Okay, now if all of these coefficients right there can simplify, then we want to simplify it down, and those will all divide by 6. So 6 square root of 6 divided by 6 just leaves you with the square root of 6. 6 square root of 2 divided by 6 just leaves you with the square root of 2. And 12 divided by 6 is 2. And this is your final answer. Okay, all right, now we're getting down to where we have a binomial in our denominator. So when you have a binomial in the denominator, you have to multiply by the conjugate. And the conjugate is just the opposite sign right here. So we are multiplying both the numerator and denominator by 4 minus the square root of 2. Okay, so you're doing it on both of them. So 4 times 4 is 16. 4 times the negative square root of 2 is negative 4 square root of 2. In our denominator, we have 4 times 4 is 16. 4 times the negative square root of 2 is negative 4 square root of 2. Square root of 2 times 4 is a positive 4 square root of 2. And square root of 2 times negative square root of 2 is negative square root of 4. So what happens here is that the negative 4 square root of 2 and the positive 4 square root of 2 are going to cancel each other out. And over here, the square root of 4, that turns to a positive 2. So it cancels out all of our radicals in the denominator. Okay, so then that is going to leave us with 16 minus 4 square root of 2 over 16 minus 2 is 14. Now, if you can simplify, you want to simplify it down. And these numbers right here, the little triangle, all divide by 2 so we can simplify. So 16 divided by 2 is 8. Negative 4 divided by 2 is negative 2. And 14 divided by 2 is 7. So that's our final answer. Okay, so on 16, same thing. So the conjugate of this is 6 plus the square root of 5. So 2 times 6 is 12. 2 times the square root of 5 is 2 square root of 5. 6 times 6 is 36. 6 times the square root of 5 is 6 square root of 5. Negative square root of 5 times 6 is negative 6 square root of 5. Negative square root of 5 times the square root of 5 is negative square root of 25. Okay, these cancel. Square root of 5, square root of 25 is 5. So this turns into 12 plus 2 square root of 5 over 36 minus 5 is 31. Okay, those numbers do not simplify because 31 doesn't divide by anything. So that's your final answer. 17, the conjugate of the denominator is 1 plus 4 square root of 2. So square root of 3 times 1 is the square root of 3. Square root of 3 times 4 square root of 2 is 4 square root of 6. 1 times 1 is 1. 1 times 4 square root of 2 is 4 square root of 2. Negative 4 square root of 2 times 1 is negative 4 square root of 2. Negative 4 square root of 2 times a positive 4 square root of 2 is negative 16 square root of 4. Okay, these middle parts cancel. The square root of 4 is 2. So we have the square root of 3 plus 4 square root of 6 over this right here. That is negative 16 times 2, which is a negative 32. And we still have that 1 and negative 32, which becomes a negative 31. These are not going to simplify, so that is your final answer right there. Okay, on this one, the conjugate of this is the square root of 5 minus the square root of 3. That's what we're multiplying by. Okay, so 5 times the square root of 5 is 5 square root of 5. 5 times the negative square root of 3 is negative 5 square root of 3. Negative square root of 5 times the square root of 5 is negative square root of 25. Negative square root of 5 times negative square root of 3 is a positive square root of 15. And this is over. Square root of 5 times the square root of 5 is the square root of 25. Square root of 5 times the negative square root of 3 is negative square root of 15. Square root of 3 times the square root of 5 is a positive square root of 15. Square root of 3 times the negative square root of 3 is a negative square root of 9. Okay, so our middle parts cancel. The square root of 25 is 5. The square root of 9 is 3. In our numerator up here, the square root of 25 is 5. We also want to simplify that down. So we have 5 square root of 5 minus 5 square root of 3 minus 5 and then plus the square root of 15. And this is all over 5 minus 3, which is 2. Okay, this will not simplify, so that is your final answer right there. Okay, 19, so the conjugate of this is 2 minus 2 square root of 7. That's what we're multiplying by, so 3 times 2 is 6. 3 times negative 2 square root of 7 is negative 6 square root of 7. Square root of 7 times 2 is a positive 2 square root of 7. Square root of 7 times negative 2 square root of 7 is negative 2 square root of 49. 2 times 2 is 4. 2 times negative 2 square root of 7 is negative 4 square root of 7. Positive 2 square root of 7 times 2 is a positive 4 square root of 7. 2 square root of 7 times negative 2 square root of 7 is negative 4 square root of 49. Okay, so these cancel. Square root of 49 is 7. Same thing up here, 7. Okay, so we have Negative 2 times 7, this whole thing right here becomes a negative 14. I'm actually going to rewrite that. I'm going to say 6 and then minus 6 square root of 7 plus 2 square root of 7, and then negative 2 times 7 is negative 14, and this is over negative 4 and 7, that becomes a negative 28. So we have 4 minus 28. Okay, now let's simplify everything. So we have 6 minus 14 becomes a negative 8. Okay, these right here we can combine together because they have the same radical. So negative 6 plus 2 is negative 4 square root of 7. And 4 minus 28 becomes a negative 24. Okay, now can we simplify this more? We have a triangle right here that those all divide by negative 4. So yes, we can simplify. Okay, so negative 8 divided by negative 4 is a positive 2. Negative 4 divided by negative 4 is a positive 1, which we don't have to write in front of that, so we can just say square root of 7. Negative 24 divided by negative 4 is a positive 6. And that's our final answer. And no, you would not simplify this again because this number right here is a 1. Okay, last one, the conjugate of this is 3 plus 4 square root of 6 is what we're multiplying by. 8 times 3 is 24. 8 times 4 square root of 6 is 32 square root of 6. Negative square root of 6 times 3 is negative 3 square root of 6. Negative square root of 6 times 4 square root of 6 is negative 4 square root of 36. And this is over 3 times 3 is 9. 3 times 4 square root of 6 is 12 square root of 6. Negative 4 square root of 6 times 3 is negative 12 square root of 6. Negative 4 square root of 6 times 4 square root of 6 is a negative 16 square root of 36. All right, these cancel. Square root of 36 is 6. Okay, so this turns into, we have 24. This is a negative 24. 32 square root of 6, negative 3 square root of 6. We can combine that together because they have the same radical. So 32 minus 3 is 29. So we have 29 square root of 6. Okay, down here we have 9. And we have negative 16 times 6 is negative 96. Okay, simplifying more. These 24s are going to cancel each other out. So 24 and negative 24 cancels. Okay, so we have 29 square root of 6 over 9 and negative 96 is negative 87. Okay, now can those simplify? We can actually divide negative 87 by 29. So those actually both divide by 29, which means that this simplifies down because 29 divided by 29 is 1. So you just have the square root of 6. And negative 87 divided by 29 is negative 3. And that is your final answer right there. Okay, so you always want to get rid of the radical in the denominator. If it's just a monomial, meaning that there's not an operation in the denominator, then you multiply by whatever that radical is. If you do have an operation down there because it's a binomial, then you're multiplying by the conjugate. So the conjugate is just the opposite sign of that. That's it. And then you're multiplying and simplifying down using the rules that we've already learned.